All right, we now have Module Test 10 Review Part 2. We're going to talk about molality. We're also going to talk about the change in freezing point and boiling point. So, first, molality. Remember, molarity was a capital M. Molality is a lowercase m. And molality is going to be the number of moles of a solute divided by the number of kilograms of a solvent. All right, so you're going to use molality when you have a solution that you are working with, something dissolving into something else. Okay, we worked a lot of those the week that I was out, and you did some of the labs. You were dealing with solutions. You were adding things to water and whatnot, boiling it, cold, or whatever you were doing. You dealt with solutions. Okay, so molality deals with solutions. So because we are in high school chemistry, it is not always going to be as easy as them giving you the moles and giving you the kilograms and you just doing one division problem. All right, so for example, they may give you a problem that looks like this. What is the molality of a solution of 100 grams of magnesium nitrate dissolved in 500 grams of water? Okay, so if you see, we have 100 grams of something and we have 500 grams of something. We want moles and we want kilograms. This does not even tell me what is my solute and what is my solvent. I have to figure that out by just reading the problem, right? So something that is super helpful in my life to remember is that dissolved in has a V. I'm just gonna do this. And that is your solvent. Your solvent is what is dissolved in. So here's water. I've got a glass of 500 grams of water, and I'm dissolving this inside of it. All right, so this is my solvent, is my water, which means my solute is this guy here. It's what's getting put into it, magnesium nitrate. All right, so let's look over here. My solute needs to be in moles. I have grams, but I know how to change grams into moles because I know about stoichiometry, right? So I've got 100 grams of magnesium nitrate, and I want to change it into moles of magnesium nitrate. And so I'm going to look on the periodic table. I'm going to add the atomic mass of magnesium once, nitrogen twice, because see this 2 over here, and oxygen 6 times, because we're doing 3 times 6, right? So I'm going to add all those things together. What is that going to give me? 148.3 grams. All right, so I'm going to cross that out. 100 divided by 148.3 grams. Huh. Did I do that wrong? Hang on a second. Let me just double check something. Okay, is 0.6743 moles of magnesium nitrate. Now, notice how there's 4 significant figures there. It's because there's 4 significant figures here. I know that there is no significant figures there, and here it shows 3, but when I added up all my atomic mass, there was 4, and so I'm going to keep it right now at 4, okay, because my atomic mass had to be that number. All right, so now I know moles of my solute, so I know this top part, and we're going to get to that in a minute. Now I want to find kilograms of my solvent. Well, it's 500 grams, so I just need to do a quick conversion from grams to kilograms. Right, y'all, some of you can totally do this in your head. That's great. I'm going to put H2O because I know that's water. It's quicker than writing water. Kilograms for 1,000 grams. It's going to give me 0.5. It's really 0.5000, but like that's dumb. We're not going to write all of that, right? So now I just need to do this divided by this divided by this. So I'll just set up one last problem, 0.6743 divided by 0.5, and that's going to give me 1.349 molality. Okay, easy peasy. Molality is not that bad. You do have to do a little bit extra work sometimes to find the moles, to find the kilograms, but it's not so bad. All right, so you're gonna have a couple questions on your test. Now, sometimes they may give you the molality and maybe the moles of solute, and then you're looking for kilograms. That's not hard. That's just like, it's just algebra, all right? You know that you just have to multiply those two things together or multiply those two things together to get the answer. Here we're dividing, but if there's something over here and you only have one of these, then you'll multiply across and that'll be your answer. So don't get frustrated if they give you the molality and they say, well, how many moles of solute? Okay, well, find your kilograms of solvent. Set up a problem. You can find it. It's easy. Well, I mean, I say it's easy, but the algebra of this problem is easy, right? Okay, so that's that for molality. Now, I am not going to do examples of this next thing. I'm going to talk about it a little bit, and then I'm going to have you look in your book, because there are some really great examples on pages 369 to 373, maybe a little bit further beyond 373 in your textbook, where they break apart these problems like step by step and tell you how they found it and where they got that information from. And I really couldn't do a better job with it. If you would just look in your book at the examples, they do a great job. And if you follow those examples for the questions on your test, I think you'll be fine. Okay, so what am I talking about? I'm talking about the change in water's freezing point. That's the first one. Change in water's freezing point. All right, and it's this really fun looking formula where we have a triangle, which is actually delta. Delta T equals negative I times this KF, which is a freezing point constant, I'll write it again, times the molality. All right, we'll talk about this in a minute. And then the next thing we're going to do is something called the boiling point elevation, which is a very similar formula where you have the change in temperature equals I with no negative sign, notice that, times this, which is different, but not really. All right, so I'm going to tell you what all these things mean, because this looks like a bunch of gobbledygook, and you're not going to know what to put in what spots. Again, if you read the pages, I think you will, but it may help just to have someone explain it to you. So anytime you see a triangle like that in math, in physics, in chemistry, in science, it's going to mean the change. The change. Delta means the change. So when you see a delta T, it means the change in temperature, okay? The change in temperature. It's going to be an answer. Probably in degrees is what you're looking at. All right, this little I in this chemistry problem, not all math, is the number of molecules. I'm going to say number of molecules. Really, it's ions, because I for ions, that the solute splits into when dissolved. And so it should tell you a number if you're trying to find the change in temperature. Maybe you'll have to find that number, but this is just a number of molecules. KF. KF is the freezing point depression constant. Now, they will tell you this number normally, unless they tell you every other thing, and then you have to find it. This changes depending on what you're freezing. So there's like a constant number, like what is the freezing point of water? What is the freezing point of aluminum? What is the freezing point of oxygen? So that's what this number is. It's the freezing, if you could read that, point depression constant. And they will normally tell you that in a problem. If you're trying to figure out the change in temperature, it'll say, hey, by the way, the K sub F is 1.89 degrees Celsius M. Sometimes it's written like this. Okay. And then here we have molality, which, if you remember, is number of moles of the solute divided by the number of kilograms of the solvent. Sometimes they will be evil and they'll make you actually figure that out when you're trying to do this problem, and it's like a bajillion steps, but you know how to do that now. We've done it, and you just got to find all the things to plug in. Boiling point elevation, if you see, it's a very similar looking thing. The only difference is over here we have a negative, and over here we have a positive, right? KB just like this is the F, the freezing point depression constant. This is called the boiling point elevation constant. So what is the boiling point of whatever that molecule is, or the atom, the element rather? Molality, this is M, molality. So all this is the same explanation. This is just different. And again, they should give this to you unless they give you all the other three things and you're trying to find it out. Again, this is just basic algebra. You've got three things multiplied together trying to find an answer. Like pretend this is X and this is 2 times 3 times 4. Okay? It's not difficult. You just have to find them and plug them in. All right, so once again, that is going to be on these pages in your textbook, and I believe that is everything that you need to know to do the math portion of your test. Good luck. Please try it. All right. These are worth so many points. And if you just say, forget it, then your whole test score is going to go down. There's no point to even do the multiple choice questions at the beginning because they're not worth enough if you just ignore all of this. Right? Try it out. If you don't get the answer at all, send me a picture. Take a picture of your work that looks like this. And some of you post it like as a comment in the test, like on Google Classroom where the tests are. Some of you have posted your work before so that I can see what you're doing, and that is helpful for me because I can tell you what you're doing wrong, or I could see like, oh wow, they got all the way to the last point and then they messed it up. I'm going to give them 3/4 credit for this, right? I would love to give you as much credit as possible. So, ask me questions, email me, send me pictures. As a reminder, I push this all the way to the end of next week. But that doesn't mean that you don't start Module 11. All right, you should take this as soon as possible and start Module 11 because we will have Module 11 test coming up shortly as well, and I don't want you to get overwhelmed with these tests. All right, have a great rest of your weekend. Bye.